Okay, in the last few videos we've been talking about linear transformations, and we talked about how if you added a constant k, the parent function shifted up or down. It was a vertical translation. If you subtracted a constant h inside the parentheses, okay, then it would be a translation from left to right. It would move either left or right, and it was always opposite, right? If you subtracted 3, it moved to the right. If you added 3 or subtracted the negative 3, it moved to the left. When you multiply it by an a, it either stretched vertically, it shrunk vertically, or it reflected over the x-axis. So we're going to actually see these transformations happen, multiple transformations happen in this function right here. Now I've written it out and I've also graphed it. Okay, we're gonna start out with the parent function and see how we're going to transform it into this purple function. When you're doing a transformation, you can actually go off of PEMDAS. Now we don't have any exponents, so we probably won't be needing this one, but we are multiplying and we are adding, we are adding and we are subtracting. So let's kind of go off of that. So I'm going to start off with my parent function, f of x equals x, and it looks something like this. And so let's start, parentheses. When we add 3, now remember that's subtracting a negative 3, so we're going to shift that over to the left 3 units, 1, 2, and 3. Okay, and so now we're finished with that. Let's move on. Now let's multiply it by the negative 2. Now I'm going to split this into parts. I'm going to first do the negative, and then I'm going to multiply it by 2. So remember, that's two different transformations. So keep in mind that the reflection is over the x-axis, which means, we talked about this last time, that the distance here from the x-axis to the function should be the same distance on the other side if it's a reflection. So this should be the same distance up here. So since I'm noticing this point is sitting at 3, right, at a y-intercept of 3, and so that would mean it should sit at a y-intercept of negative 3 after the reflection. Here it's x equals 0, which means it should stay there. And we should end up getting something that looks like this. Okay? So that was the negative part, the reflection. If we do the times 2, last time we said that if you multiply by 2, the height would just double. So we'd end up doubling the height. And so since it's at 3, we should get a point at 6. Okay? We end up doubling the height here. Should get a point somewhere up here. Okay? And if I take my line and pass it through those 2 points, let's see, I think I overshot it just slightly. We should end up getting 2 parallel lines. Okay? And so from there, we've done the parentheses, we've multiplied, there's no division. The addition part was inside the parentheses, so we're done there. We just need to subtract the 5. Okay, and so that would mean that all we have to do is shift it down 5 units. 1, 2, 3, 4, and 5. And you can see that the line is now, the pencil is now on that line that we thought this function was.